Section 1.6, Absolute Value Equations and Inequalities. The absolute value of x is defined as if x is greater than or equal to 0, then the absolute value of x equals x. So the absolute value of 2 is 2. If x is less than 0, then the absolute value of x is the opposite of x. So the absolute value of -3 is 3. Properties of absolute values. The absolute value of a product is the product of the absolute values. So if you're taking the absolute value of two things multiplied together, you want to take the absolute value first and then multiply them. That's true for any real numbers a and b. B, the absolute value of a fraction is the fraction of the absolute values. So you take the absolute value of the numerator, you take the absolute value of the denominator, and then you divide. Of course, the denominator cannot be equal to 0. The absolute value of the opposite of a number is just the absolute value of the number for any real numbers a. So let's simplify these absolute value problems, leaving as little as possible in the absolute value. So this is the absolute value of a product. We want to take the absolute value of each factor. The absolute value of -9 is just 9. What is the absolute value of y? We don't know. It depends upon what y is. If y is positive, then it would be y. If y is negative, then it would be the opposite of y. So since we don't know, we have to leave it. What about this? We have the absolute value of a product, 6b squared. So we're going to take the absolute value of the individual factors and multiply them. Now the absolute value of 6 is easy. That's just 6. What about the absolute value of b squared? B has to be a real number. So if you square a positive number, you get a positive number. If you square a negative number, you get a positive number. If you square 0, you get 0. So the absolute value of b squared is always going to be greater than or equal to 0. So the absolute value is not really doing anything. We can change that to just the 6b squared. The absolute value of x minus y. Now this one is very interesting. We don't have a rule for the absolute value of x minus y, or the rule for subtraction. Let's think about this for a minute. If x minus y is greater than 0, in other words, if x is greater than y, if x is greater than y, then that's going to be positive. And so the absolute value, if that is true, of x minus y would be equal to just x minus y. But if x minus y is less than 0, that's different. That means x is less than y. Then what happens? The absolute value of x minus y is negative, so the absolute value is the opposite. It would be y minus x. So what is the absolute value of x minus y? I don't know. It's just the absolute value of x minus y. We can't really determine what that is. We can't simplify it further until we know whether or not x is greater than y or x is less than y. We just don't know. Absolute value principle. For any number p and any algebraic expression x, the solution of the absolute value of x equals p is those numbers that satisfy x equals negative p or x equals p. So if you have the absolute value equal to something, then that something that you're taking the absolute value of must be a positive p or a negative p. If you have the absolute value of x equals 0, then whatever you're taking the absolute value of, that x must be 0. And if you take the absolute value of something and you say it equals a negative number, that has no solution because the absolute value is always positive. So our first example, the absolute value of y equals negative 4. How could you take the absolute value of y and get negative 4? That makes no sense. The absolute value is always positive. There is no solution to this problem. The absolute value of 3x equals 24. That means that 3x must be 24, or 3x must be negative 24. So that gives us two problems. We have to solve both of them. We need to isolate the x, divide by 3, x equals 8, or divide by 3, x equals negative 8. Do both of those work? We can always check our answers by substituting them into the original problem. X equals 8, substitute into the original problem. You have the absolute value of 3 times 8. Does that equal 24? Yes, it does. That's fine. 24, the absolute value is 24, and that does equal 24. What about x equals negative 8? Let's substitute that into the original problem. 3 times a negative 8 is negative 24. Take the absolute value of negative 24. Do you get 24? Yeah, you do. So that's correct. That is a correct solution. Whenever you can put the solution back into the original equation and you get a true statement, you know that you have worked the problem correctly. So for this problem, we have a plus 6 equals 10. That's one possibility. Or perhaps a plus 6 equals negative 10. Let's solve those two equalities. Subtract 6 from both sides. A equals 4. That gives us one solution. Or subtract 6 from both sides in this case, and we find out that a equals negative 16. Do both of those work? Well, substituting them back into the original equation, for a equals 4, we have 4 plus 6 is 10. The absolute value of 10 is 10. That works. Substitute negative 16 back into the original equation. You have negative 16 plus 6 is negative 10, and the absolute value of negative 10 is positive 10. So that also works. We have two correct solutions. Let's solve this equation. We have the absolute value of 2x plus 3 equals 25. So either 2x plus 3 equals 25, or 2x plus 3 equals negative 25. Let's solve both of these equations. This first equation, how should we solve it? We need to isolate the x term. That gives us 2x equals 22. What next? Divide by 2. X equals 11. The next equation, isolate the x term, subtract 3 from both sides, 2x equals negative 28. What next? X equals negative 14. So we have two solutions. Can you substitute them back into the original equation? Does it give you a true statement? Yes, both of them do. This situation is a little bit different because we have a problem here. 3 times the absolute value of x minus 7 equals 11. We only have problems that, or rules for solving problems that have the absolute value of x or the absolute value of an expression containing x that are isolated. We need to isolate the absolute value of x. We will do that by first adding 7 to both sides. That gives us 3 times the absolute value of x equals 18. Let's keep isolating the value of x. And we get the absolute value of x equals 6. So what does that mean? What does x equal? It could be 6, or what else could it be? -6. We have these two answers. We can substitute them back into the original equation, and that will give us true statements. So those are valid solutions. So we have solved our absolute value equations. You need to look at the next video to see the second part of 1.6.